Your heart stops. By every measure doctors use, you are now clinically dead. And yet, inside your skull, your brain isn't finished yet. For a brief window, seconds to a couple of minutes, something that looks a lot like heightened brain activity is still happening, right as everything else in your body is shutting down around it. That's the real answer to today's question. What happens inside your body during a near-death experience? Not the anecdotes alone, tunnels of light, floating above the room, a sense of peace. The measurable, recorded brain activity behind those experiences. And in the last few years, scientists have finally caught it happening, by accident, on an EEG machine. This isn't just anecdote collecting. Millions of people worldwide report some version of a near-death experience after cardiac arrest, surgery, or severe injury, describing strikingly similar features across different cultures and belief systems. A sense of leaving the body, moving through a tunnel toward light, and an overwhelming feeling of calm. For decades, doctors assumed these were simply hallucinations from an oxygen-starved brain, impossible to study directly, because nobody could predict exactly when a person was about to die while they happened to be hooked up to brain monitoring equipment. That changed only recently, almost entirely by accident, when a handful of patients died while researchers happened to already be recording their brains for completely unrelated medical reasons. Here's the one concept you need. Brain activity is measured in electrical waves at different frequencies, and gamma waves, the fastest of these, are strongly associated with alertness, focused attention, and conscious experience in a healthy, awake brain. Slower waves, like delta and theta, dominate during deep sleep, anesthesia, or coma, when the brain is largely offline. So if a dying brain suddenly showed a surge of fast gamma activity, right as the rest of its systems were failing, that would be a strong hint that something conscious-like might still be happening, even as the body was failing around it. So let's walk through what researchers have actually recorded, stage by stage. First, in 2013, researchers at the University of Michigan induced cardiac arrest in rats under controlled laboratory conditions and recorded their brain activity throughout the entire process, from normal waking activity through the moment the heart stopped. In the 30 seconds immediately after the heart stopped, the rats' brains showed a surge of highly organized gamma wave activity, more synchronized across brain regions than during normal waking behavior. A finding that surprised the research team enough that they double-checked their equipment before publishing it. Then, in 2022, doctors got an unplanned human version of the same data. An 87-year-old man was being monitored with EEG for unrelated seizures when he suffered a fatal cardiac arrest during the recording, giving researchers an unprecedented, continuous window into a real human brain in its final minutes. In the 30 seconds before and after his heart stopped, his brain showed that same surge of gamma activity, concentrated in a region toward the back of the brain called the temporoparietal junction, an area already known from other research to activate during dreaming and out-of-body experiences. A year later, a larger study at Michigan Medicine monitored 4 comatose patients as they were taken off life support, with each family's permission, after doctors had determined there was no further medical hope. In 2 of the 4, removing ventilator support triggered a measurable spike in heart rate alongside a fresh surge of gamma activity, in what researchers call the brain's hot zone for consciousness, where the temporal, parietal, and occipital lobes meet near the back of the skull. Here's the twist that makes this genuinely strange. The gamma activity in these dying brains wasn't just present, it was coordinated. Different brain regions were firing in coupled, predictable patterns, the same kind of cross-frequency coordination seen in healthy people actively recalling memories or dreaming vividly. That's exactly the kind of brain signature some researchers link to the classic life review, reported by near-death survivors, the sensation of vivid memories flashing past all at once, as if the brain were running one final, compressed replay of a lifetime of experience. But before this gets treated as proven fact, other researchers pushed back hard. A 2022 critique pointed out that the actual gamma power recorded after cardiac arrest was still extremely low in absolute terms, just relatively higher than the even more suppressed alpha, beta, and delta waves around it, and questioned whether the exact moment of cardiac arrest was measured precisely enough to draw firm conclusions at all. Some critics have even suggested the signal could partly be an electrical artifact from a failing heart and brain, rather than genuine evidence of an experience taking place. That's the edge of what we know. We now have real recordings of a distinctive electrical signature in the dying brain, but whether that signature represents an actual conscious experience, a rich inner world flashing past in someone's final moments, or simply a chaotic electrical echo with no one home to experience it, remains one of neuroscience's most contested open questions. So here's the honest answer. Something measurable and organized really does happen inside a dying brain. A final documented surge of activity in exactly the regions tied to memory, dreaming, and awareness. What we still can't say, with any scientific certainty, is whether anyone is actually there to notice it, or whether we're simply watching the last coordinated flicker of a machine finishing its shutdown sequence. There's a very different kind of instant ending waiting in our next episode, one measured in seconds rather than minutes. What happens if you were suddenly exposed to the vacuum of space without a suit? That's a story for another episode in this series, so subscribe if you don't want to miss it. I'll see you at the edge.